ahead of the 2026 EV Challenge, it's now time to make a couple of updates. So the first thing that we're going to be working on this year is aerodynamics. You can see on the left-hand side here, we have our old foam and carbon fiber wing, which was simply expanded polystyrene foam with a single layer of carbon fiber kind of shoddily put over the top. We have exposed steering rods here at the front of the car, and also that wing that sits on the side there isn't really covering out by the steering assembly. So there's still some areas down here where we can encounter quite a lot of drag. We also want to get a little bit of downforce onto the front of the car. We could hear from last year's video, there was a bit of scrubbing at the front of the car as it kind of understeered a little bit across the track. So the most important thing is actually covering up that front axle there. Moving on down the car, we have these side mirrors. Now, as per the rules, they have to be able to move, so we have to contend with that. But this is effectively a flat surface that's exposed to the airstream. So we want to try and make that as streamlined as possible. And we've already started working on the aerodynamic changes of the car with this side mirror cover, which provides a nice streamlined change here, as well as guiding some of the airflow towards the back of the car with this vertical end plate. Finally, we have the back of the car here, where there's a big low pressure region at the back of the car. So we'll be wanting to work on improving that as well if we have time. So the EV Challenge is all about compromise. It's a compromise of weight, aerodynamics, manufacturability, and cost as well. When we're coming up with changes to the car, we're really looking at whether or not it makes sense to even implement something. So for instance, the side mirror cowling that I showed on the other side, we have one for this side here too. When we're coming up with that design, we're looking at the aerodynamic change. So this area here is about 12 centimeters across and 11 centimeters wide to the bottom. So it's a very small surface area, but if we jump across to the whiteboard, we'll be able to see the change that this might make over the course of an hour. Okay, so to work out our engineering compromise, we want to start with two formulae first. So the first is power for aerodynamic. So this one here, we'll call this P aero for aerodynamic drag. This is equal to half the air density, which is usually 1.2 kilograms per meter square cubed. You can find that online, times by velocity cubed, times by the surface area, and then times by our coefficient of drag. So the coefficient of drag will work out shortly, but this one here, our velocity is going to be 10 meters per second because we're doing 36 kilometers per hour average, and our surface area will be able to be calculated by the 0.1, so 10 centimeters or 11 centimeters across, times by 0.12, which we'll calculate shortly. And then our coefficient of drag will work out in a sec. The other one we have to look at is the power of rolling resistance. And this one here, we're really just looking for the delta of that. So the power of rolling resistance is equal to the rolling resistance or coefficient of rolling resistance times by 9.8 times by the weight of the vehicle. And in this case, the weight of the change that we're going to make to the vehicle. So that there, each of those side cowlings is about 200 grams, so we'll put 0.4. And then over here, we'll also times it by the velocity, so times it by 10. So this one here, the rolling resistance of a wheel is about 0.08. So that will actually become 0.024 because we've got 3 wheels, times by 9.8 times by the weight of 0.4 times by 10. So we'll be able to calculate that in a second. Before we go through and do the calculations for the aero and for the rolling resistance, for the coefficient of drag, what we're looking at doing at the moment with this whole design is replacing what is effectively a rectangular prism, which is the mirror sitting across here. And this has a CD of roughly 1. It's 1 to 1.4, but it's a coefficient of drag of roughly 1. What we're really going to replace it with is something that looks kind of like that goes across. And it's a half aerofoil. So that's the front there. And this one here is very close to the shape of a bullet, which has a coefficient of drag of 0.295. So we're really looking at a 3 times reduction in the coefficient of drag, which should have a large impact on the aerodynamic drag. So we'll go ahead, do the calculations, and then come back. Okay, so going ahead, we've calculated the power required to overcome the rolling resistance, the additional rolling resistance of the weight of the side mirrors. So we're looking here at an extra 0.9408 watts. Now, over the course of an hour, that's going to give us 0.9408 watt hours of energy required to overcome the rolling resistance. And we're going to just write this number up the top here. So P rolling equals 0.9408 watts. And now we can rub that away and we'll expand upon the aerodynamic drag. Right, so expanding upon the power required to overcome aerodynamic drag, the original amount would have been half times half times 1.2, which is the air density, multiplied by 1000, which is velocity cubed, 10 by 10 by 10, multiplied by 0.0132, multiplied by a coefficient of drag of 1. And that original amount is 0.6 or 600 times by that, which would be roughly 7.8 watts. So 7.8 watts required to overcome the aerodynamic drag of the flat side mirror. And now we actually are looking at reducing it by 3 times. So this being 1/3 of that, we can reduce this by 3 times, which gives us 2.6 watts required, which means that by adding this side mirror cowling, we're saving ourselves 5.2 watts there. But then we have to add back the power required to overcome the additional rolling resistance of 0.94 watts. So we end up saving ourselves about 4.25 watts. And over the course of an hour, 5.25 watt hours. Now, given that we have about 650 watt hours, this is not an insignificant amount. It's about 0.6 to 0.7%. But when we're looking for every single possible gain that we can get, this is a very easy gain for us to get for the vehicle. So as we can see, definitely makes sense to be adding our side mirror cowling on. And we'll be optimizing this shape and then adding some sticker flakes to hold it on to the side. And as we calculated, this will actually make a change over the course of the hour.